Welcome to the Explainer. So, let's talk about software security. Right now, it feels like we're in this massive arms race with AI. But here's the scary thought. What if it's a race we just can't win? Today, we're going to dig into whether our whole approach to defense is fundamentally broken and, what could possibly come next.
And right away, you can see the problem. AI is a total double edged sword. I mean, on one side, it's this incredible tool for innovation, right? Developers can build stuff faster than ever before. But the flip side is that it's also a powerful weapon for the bad guys. They can now write some seriously nasty malware, like almost instantly.
And that's what kicks off this escalating arms race. The thing is, though, the defenders, the good guys, are kind of set up to fail from the get-go. They're already fighting an uphill battle.
Okay, so here's the absolute core of the problem. It all comes down to speed. An attacker, they can create and launch an exploit in one quick move. Boom, done. But for the defenders, oh, it's a whole different story. Just creating a fix, a patch, that's only step one. After that, they have to test it like crazy to make sure the fix doesn't, break everything else, and only then can they actually roll it out.
And that delay, that testing window, that is the fundamental flaw. It's a golden opportunity for adversaries to wreak havoc. It's this built-in weakness in the system that means if you're just reacting to threats, you're always going to be playing catch-up.
And if that wasn't bad enough, there's this really dangerous paradox happening. The very tools we're relying on for security, yeah, they can actually become our biggest points of failure. Just think about it for a second. You have a huge security platform or a dominant cloud provider, right? It's solving tons of problems for everyone. But because everyone is using it, if just one thing goes wrong with it, the fallout is catastrophic. The answer to the problem literally becomes its own massive problem. This whole thing even extends down to the software itself. You could have a bunch of different components, say an app, some middleware, or a server, and each one on its own is perfectly secure, certified and everything. But what happens when you make them all work together? Well, the crazy complex ways they interact can create brand new vulnerabilities that nobody saw coming. It's a classic case of the whole being, well, weaker than its parts. This is what the experts call the composition dilemma. And this leads to an absolute nightmare for operations teams. It's like playing a game of whack-a-mole. They know they need to apply a critical patch, but they're terrified it's going to break the middleware, which then takes down the whole app. So they're stuck in this gridlock, this catch-22, where fixing one thing might break two others. So, okay, if we can't win the race, and our current answers are actually making things worse, are we just stuck? Well, the experts we're looking at today argue there is a third way, but it requires us to completely change how we think about the problem. And here it is. The idea is that we don't really have a security problem, we have a software problem. That's a huge shift. Instead of endlessly chasing after bad guys, what if we just fundamentally managed the software itself? And that brings us to this concept of deterministic trust. Basically, you stop playing defense. You stop trying to detect all the bad stuff, and instead, you create a state where only known, trusted software is allowed to run. Period. It's a simple idea, but it is incredibly powerful. So this model of trust, it's built on three really important pillars. You can think of them as three questions you have to ask about every single piece of software in your environment. Let's dig into what they are. Okay, first up is provenance. That's just a fancy way of asking, where did this come from? Is it from a trusted source, like your own developers or maybe Microsoft? Or did it come from some update with sketchy, unsigned files? Next is integrity. Has it been messed with? Is the software acting the way it's supposed to, or has it been compromised? And finally, authority. This one's huge. Should this even be here? I mean, why is a web browser running on a critical production server that has no business having one? Just answering that last question can wipe out a massive chunk of your risk. So that's the big idea. But how does an organization, led by its CISO, actually do this? How do you adopt this new way of thinking without, well, breaking everything? Turns out there's a simple, pretty powerful playbook for it. It's a three-step journey called VIS, Help, Solve. And it's all about building confidence and getting real results without disrupting the whole business. Step one is visibility. And this is key. You don't block anything yet. You don't change a thing. You just show them. You show the organization the risks they didn't even know they had. You show them something they can't unsee. And this is where it gets really powerful. Imagine showing a CISO that a staggering 97% of their critical vulnerabilities could be just gone, mitigated.
not by patching, but just by controlling what's allowed to run. When you show them that, the problem becomes crystal clear, and it's impossible to ignore.
All right, so once they see the problem, you move into the help phase. This isn't about forcing a change. It's about working together. You help them prove the solution works, maybe on a smaller scale, and you plan out how to implement it. It's all about building that confidence.
And finally, you solve it. You flip the switch. You let the system do the work. The protection is turned on, and it autonomously enforces that trust model you've built together. It just works, delivering the outcome you wanted.
Which brings us to the crucial point here. As the software world gets exponentially more complex, the old ways of doing things are just breaking. This unwinnable arms race isn't just a scary idea, it's becoming our reality. So that leaves all of us with a final thought to chew on. If today's security answers inevitably become tomorrow's problems, what is your third way?